Hello, everyone. It's my pleasure to see you all here virtually and to host this session on the built environment and efficiency via robotics. We have a great lineup of panelists and a co-moderator with us today. So, quick introduction of myself. I'm Mirko Kovac. I'm running the Laboratory of Sustainability Robotics between EPFL in Lausanne and EMPA in Zurich. And we are focusing on novel sustainability robotic solutions, which include environmental sensing methods, as well as new construction tools and 3D printing with drones, manufacturing with drones, and so on. So with me today is Domitil Lusha, who's a project manager in the lab. I'll hand over the word for her for a quick introduction.
Thank you, Mirko. Hello, everyone. I'm very happy to be here today. I'm Domitil Lusha. I'm a project manager in the lab, and my background is in climate and environmental science. So I'm particularly interested in strengthening the links between robotics research and climate and environmental science. And yes, over the past 2 days, I've seen the panel session spark some very engaging conversations. So I'm very much looking forward and curious about where today's discussion will take us.
Great, thank you, Domitil. And that's exactly the spirit we have here on interdisciplinarity. So I'm from a robotics background, Domitil from environmental sciences, and the panelists, many of which come from architecture and related disciplines in construction. So a quick introduction from everyone. We can start maybe with Norhan Bayomi, who's co-founder and CEO of Lamarr.AI. So I think there's a slide maybe for Norhan.
Good morning, everyone.
Great. Yes. Hello.
Good morning. My name is Norhan Bayomi. I am a research scientist at MIT. I direct a new group called Sierra, which is a research group that working in the intersection of spatial AI and environmental reasoning for the built environment. I'm also a co-founder of a company called Lamarr.AI, which is what you see on the screen on the right side. Which basically a spin-off from a research project that has been ongoing over the past 9 years almost between Georgia Tech, MIT, and Syracuse University. So mostly my work is in the intersection of spatial AI, robotics, and climate vulnerable built environment. So on the research side, I'm just giving an example of one of the projects that we worked on, which is in Colombia. So this is a project where we deployed drones as a diagnostic tool to help us understand landslide risks in a city called Mokwa. So this city is very interesting because it's there. I think in 2017 there was a rapid avalanche that killed more than 600 people in just a matter of minutes. So we were trying to understand how can we use technologies like aerial robotics doing the sensing and machine learning methods that would fuse drone imagery with terrain data to produce landslide susceptibility. So this is just one of the projects where we're using robotics as an instrument for sensing. On the Lamarr side, which is kind of tackling a very similar problem, we're using also drone with thermal imaging to identify weak links in the built environment, especially in the building envelope, because buildings constitute close to 40% of the global carbon emission. So we're trying to unlock the blind spot when it comes to building performance related to existing building envelopes using drones and AI to identify opportunities for energy efficiency.
Great. Thank you very much, Norhan. Great to have you here in the panel. Okay, so further we can introduce Ramon Weber, so assistant professor at UC Berkeley. Ramon, I think there's also a slide for you.
Great. Thanks so much for having me, Mirko, and great to see everyone. And so my name is Ramon Weber. I have a background in architecture, worked as an architect before going into research. I was also did my PhD at MIT, where I did a lot of work on kind of robotic and digital fabrication, also between architecture and the MIT Media Lab. And so now at UC Berkeley, I'm starting a research group around kind of computational design, sustainability, and kind of new technologies in architectural design. And I'm very interested in kind of how like we can enable new kind of methods of construction through kind of new fabrication systems and robotics. And a lot of my work has touched on this in like various forms around like new methods of manufacturing with 3D printing, kind of mostly around like experimental material systems. And most recently, I've been kind of also interested in thinking about how we can kind of scale these technologies up, how we can kind of learn from maybe transferring some of the ideas that we had to kind of construct more kind of experimental architecture and kind of bring them more towards analysis of like whole building stock and kind of generative design of many thousands of different buildings, and also figuring out what the opportunities for like new materials and kind of, let's say, low embodied carbon materials are in a large scale. At the moment, I don't do so much with actual robotics, but I think one of the things that most recently I think I got very interested in, and that a few research projects have started to come up with, is that a lot of like, I think, work that is really interesting that's going on currently in the robotics industry around reinforcement learning, around new kind of machine learning inside of virtual environments, is actually extremely transferable to how we train intuition for architects to design better buildings. And so there's been a lot of like really interesting ways to kind of tap into that knowledge and kind of skills that has been like built up inside of the robotics community, and figure out how to kind of transfer this to virtual design environments where we can kind of train and kind of think about architectural design in kind of this maybe not to kind of design with for robots, but kind of have architects design kind of better buildings. Yeah.
Great, wonderful. Thank you so much for your perspective. So we can move on to the next panelist, who is Stefana Parascho from EPFL. Welcome, Stefana. Great to see you here.
Yeah, thank you, Mirko. Good to see you. Yeah, I'm Stefana Parascho. I'm a professor at EPFL. I am an architect by training, but my work really lies between robotics and architecture. I look at the field of construction from two perspectives. One being really the technical one, so we work on control, we work on human-robot collaboration, communication methods, vision systems, whatever is needed to get these robotic processes to work. But we also look from the societal perspective. We look at the climate impact that construction has, and where we can come in with robotics to improve that. We look at accessibility for people and at labor, and how we can bring robotics to improve that. The work at my lab mainly focuses on human-robot collaborative construction, as we fundamentally oppose the notion of humans being replaced by robots. And instead, we really look at where robots can support human workers in a way that it improves their experience and makes the field of construction more accessible. More specifically, we develop full-scale construction methods in which humans and robots work together in order to, on the one hand side, increase robot autonomy, so to make processes more flexible. This means robots can react better. It doesn't mean that the robots do everything alone. It's really with the purpose of having flexible systems. We aim to find communication and control methods that are more intuitive to humans. And really the main goal is to enable more sustainable construction by working with less processed materials, such as found materials, reused materials from demolition. We work with concrete rubbles, we work with timber reused materials. And obviously this brings very particular challenges to robotic applications, requiring much more sensing and more reasoning capabilities in the robots. And we propose mainly applications on existing built infrastructure rather than looking at new construction. So we use robots for renovations, repair, reconfiguration of existing structures, with the aim of extending the lives of the existing buildings rather than further depleting our resources through new construction. Thank you.
Great. Thank you so much, Stefana. Good. Then we have the fourth panelist, who is Dylan Crow, CEO and co-founder of Renovate Robotics. Dylan,
hi, everyone.
welcome.
Thank you, Mirko. It's a pleasure to be here. I'm Dylan. I'm the CEO of Renovate Robotics. We build robots that automate the installation of roofing. So roofing, we like to say, is an industry that no one really thinks about until you need a new roof. But it sits at the intersection of climate adaptation, climate mitigation, and then also labor, which is one of the things that really got me interested in it. So, roofs are the first line of defense for the entire built environment between the climate and those buildings. And then, the labor pool, specifically here in the United States, that's willing and able to install those roofs is quickly dwindling. And on average, every single year, between 4 and 5 million residential roofs need to be replaced. It's a huge risk to people's lives. This is incredibly dangerous work. 50 people will fall off of a roof today while those roofs are being installed, and over 100 people will die this year installing roofs. And most of those people are migrant people. Most of them are, here in the United States illegally or on some sort of status that makes them vulnerable. So it's a particularly, pressing issue. And it sits kind of at the convergence of all of these things. And then, we also see roofing as the solution when it comes to mitigation, because roofs are the best place, to generate electricity through rooftop solar at the point of use in residential homes. So it's this kind of wonderful convergence of all of these things. My apologies for not sending a slide, but if you look there in the chat, you can see our website and pull it up and look at the robots that we build. And I'm excited to dig into the conversation with everyone.
Great. Thank you. Thank you for being here, Dylan. It's a great pleasure. So I think we see here a very strong panel, really thought leadership on architecture, materials, and robotics, really going towards a step change approach to climate resilience and the positive climate impact. So thank you, everyone, first of all, for working on that field, which is so important. So we're going to run this session is that we start with Domitil chairing the first part, and then I'll also ask some question from my side. But the most important is the audience. Please put any questions you might have, any comments, anything to the Q&A section here on the chat. We'll then select some and ask them depending on how much time there is for this session. So thank you very much. I hand over to Domitil.
Thank you, Mirko. I think, yes, we have a very interesting, very big breadth of expertise in this panel today. And what I would like first to hear is a bit more about the challenge, the specific challenge you tackle. And my question would be also more specifically, how do you see your work move the climate needle in a sector that, as Norhan reminded us, is a very high emission sector? So I would like each of you maybe to give a little bit of more detail on this aspect. Yeah, I don't know who wants to jump in first.
I'm happy to start. I'm already unmuted, I'm realizing. Yeah, so on the roofing side of things, one of the biggest challenges in roofing is just the frequency at which roofs need to be replaced. So I don't know if any of you are homeowners here in the United States, but the cost of replacing a roof is incredibly expensive. And when your roof is leaking, like, you're freaking out because your house, typically for most American people and American families, is the most valuable thing that you own. It's representative of your personal safety and security and your wealth. So, first and foremost, the way that we impact climate is that we want to build robots that install better roofs, and we want those roofs to last longer. And we want to use robotics and technology and sensors and data and all of the wonderful things that robotics have to offer to ensure that when a roof is being installed, it's being installed correctly, it's being installed, in the way that the manufacturer specifies, and so forth. And we, have great partners that help us with this. Saint-Gobain, one of the world's largest material manufacturing companies, and a leading manufacturer of roofing materials here in the United States through their brand CertainTeed is an investor and a partner of ours on this effort. But that's, I think, like only the immediate in the first way in which we're actually impacting that today. Beyond that, I think we share some of the perspectives that I think others had shared prior to the panel, and that there's huge opportunity here to not just install the built environment better in the way that it's designed to be installed today, but there's huge opportunities to rethink, how can we design systems and materials in tandem to think about how can we create more resilient structures? How can we create structures that are, far less carbon intensive? How can we create structures that are more easily installed? But I'm a firm believer in that, but I think there's a big devil in the details, and that installing a roof with a robot is already one of the hardest things, certainly the hardest thing I've ever tried to do. And beyond that, convincing the entire ecosystem of things that are required to install roofs, be that distributors, material manufacturers, migrant labor that doesn't even speak English who installs the roof, homeowners who are the ones paying for the roof to be installed, and so forth. There's a lot of different variables and people that you have to convince if you want to invent a new system that's better. So I certainly agree with the perspective, but it's very complicated. And I think it's very easy when you're not I spent a lot of time 45 feet in the air in a harness next to a robot installing a roof, and I'm very aware of the realistic challenges of it, and then also the theoretical ones as well. So I'll end with that.
Yeah, I can add to this because this ties really well to the main challenges that we're facing in the company as well. Because part of the reason why when we started the research question for both projects is like the gap of data acquisition, especially and you can see like this is in parallel between the technology that we deployed in Colombia and the technology that we built in Lamarr, is that how can we understand the existing conditions? Because if we're really looking to decarbonize, especially in the building sector, we need to have a full picture of the existing conditions of the building stock, because most of the buildings, at least in the US, were built before the year 1980. And this is a very interesting year because this is the year where the energy code started to be implemented. So as you can imagine, these building stock are already very underperforming. So one of the key things we wanted to tackle with the technology at Lamarr specifically is how can we build like a diagnostic robotic stack that could be fed with AI methods to speed up the process of understanding the existing conditions of building envelopes in general. I just want to echo what Dylan also mentioned on the challenge when you introduce a new technology to the customer side, especially when it involves like a robotic system. Drones is less challenging because it's already familiar to people. But we've seen that there is some sort of like a pushback if there's some like privacy issues. So we wanted to capture this in the technology pipeline itself. How are we preserving the occupants' privacy? So this is one of the challenges. On the research side, as I highlighted, we're mostly interested in using robotic system to acquire data in challenging environment, because this is where the big value we have seen through multiple apply projects, that in a context like the Amazon forest, where you want to see what beneath the tree canopy, I think the drone and LiDAR becomes very relevant technology that needs to be deployed, but also like how this technology could be used to create like job opportunities for the local communities to continue acquiring data and to continue working with this. So it's also a bit of another side to this data gap question. How can you build a technical capacity, especially in vulnerable communities, to continue using and leveraging these robotic systems?
I can jump in. So from where we stand and the work that we do, we work mainly with large-scale industrial robots. We really try to tackle construction at the full scale and the challenges that come with assembly and disassembly. I think that the key to our work is, you can have the best robotic system and the best performing robots out there. If you ignore the context in which this happens, it will never have an impact. So for us, this context starts with the material. Like, what materials do we work with, and how can we address the materials that can really make a difference? And that means for us really moving away from processing material, from working with really carbon intensive materials such as new concrete, but looking at what material is available, what building stock we have available, working with reused material and much less processed ones. And this also really brings the main challenges for the robotic systems, because this material is obviously not standardized. There's lots of unknowns in there. The geometries are hard to predict. The capabilities of the material are really difficult to predict. Can we use it structurally or not, and for what purposes? Basically, you would need to test every single element. So this kind of brings the key technical challenges as well that we work with, which go from sensing how can we learn as much as we can from the material, about the material, without requiring really intensive and invasive testing procedures, but also how can we get a good model of what we're working with as little data as possible. We try to use as little technology as possible. It ends up being quite a lot, but being also relatively aware of how computationally expensive lots of scanning processes are. We try to minimize that only where needed. And that's where we make the connection to the human, because yes, you can automate pretty much anything if you have unlimited resources, but there's no need to. You do have humans who have great capabilities, great intuition, great adaptability. So we try to really leverage that. You maybe don't need to recognize everything automatically about a certain building element if you have a human there that can tell you things based on their experience. So we try to combine these two sides. What can the human bring and what can the robot bring, without separating everything. That's the main challenges.
Yeah, so maybe coming back a little bit to the original question, I would also kind of add to Stefana's great point that I think retrofits, especially in places like the US or Western Europe, are like one of the most kind of important challenges, how to mitigate carbon emissions in the built environment, right? Because like there's so many opportunities. And I also think we're kind of lagging a lot behind with like, having invented new technologies for kind of design of new buildings. But I think the technologies to look at and like even when you follow an architect, how they would assess and think about existing buildings, it's usually a very like analog task, right? It has no like automation that has not found its way into it. And I think there's a lot of opportunities to kind of invent new ways for analysis that are kind of scalable and kind of help us understand how we can like better optimize these existing buildings. And I think I also maybe from my own side, kind of how to like tap into the whole kind of carbon picture. Kind of, I'm working a lot with kind of creating generative design systems and kind of looking at like design spaces of many different design iterations, something that is maybe very familiar to architects who kind of try to like, try out different design options, but usually there's not a lot of like quantifying of like what that would actually mean in terms of carbon or in terms of impacts on like different construction systems and so on. And I think it's really interesting to think about how we can kind of bring in all of these kind of quantitative insights and also kind of insights into like sustainability of buildings into like early stage design processes, and think about how the maybe construction systems that might be more automatable or that might be like be able to be done by robots in a factory for like prefabricated systems, how would those change the way how we design, right? How can we think about like what are the maybe ways how current buildings, how they're built are kind of suboptimal, and how can we kind of change and kind of mitigate that and think about what would this be at a scale. And then I think there's a big like kind of also a lot of kind of issues in thinking about, representation, where like I think we have this kind of mismatch between ways that are maybe kind of representing like buildings to kind of get data from them, and then also represent buildings to kind of design them. And I think the two have to kind of talk more to each other to kind of fully leverage kind of these kind of computational pipelines.
Thank you very much. I think we've touched upon various issues, and I've heard several times you talking about scaling up and how you scale up, and see that I heard challenges in terms of maybe regulation, maybe also acceptance, and I was wondering if you had a few words to say about what are the big bottlenecks if you want to scale up this climate solution that you see.
So maybe I can just start with that. So like in California, a lot of like the concern around like housing, for instance, but I think all across the world is also cost, right? So you have like a lot of like the people in policy and the lawmakers, they're very concerned with the climate. Especially the ones who are kind of, very progressive legislators, but they also are even more concerned with like the ongoing housing crisis, rents, not enough housing. And so they're extremely hesitant to have anything kind of sustainability related that could impact the cost of buildings. And so this has been like it's kind of a, I guess somewhat of a vicious cycle, because we will not be able to create scalable low carbon solutions without having some sort of, large scale investments from also a government side, and kind of maybe some sort of like time when things might cost a little bit more. But I think currently, for instance, in California, like no lawmaker would ever pass any bill or something that would make materials and housing more expensive. That's like a red tape. So anything that we do has to also be lower cost. And I think it's a really interesting or a really difficult challenge to kind of navigate that, because they're kind of, I think, fundamentally, opposed. And it's kind of, I don't know how to kind of leapfrog that. And that would maybe be a challenge question to everyone else, where I think, in some areas, like for instance, I'm also from Switzerland, where Stefana is teaching and working at the moment, where maybe cost is not as much of a consideration, because the government just has there's just unlimited money for like like the government to try out like new forms of affordable housing. So it doesn't matter, if it costs a little bit more. But here in the US, it's just like a no starter to begin with, and it's been really kind of challenging to navigate.
Yeah, thanks, Ramon. I think that's really touches on the core, which is to quantify the cost benefit, the energy savings, and so on, the sustainability metrics, right? And maybe I would like to take that over to Dylan, right? So really, I mean, you're in the business is really selling that, right? Proposing the cost benefits as well. So maybe could you enlighten us on your view on the energy saved with those roofs and repairs? Like, can we quantify it? Can we put on some numbers?
Yeah, so the way that we actually quantify the benefit to the contractors that we work with initially is through the cost of labor. So the goal is to install a better roof that lasts longer for the customer. That's a value proposition to the customer. The challenge is that roofing is typically, as many of you know, in construction, there's two ways you can do things. You can either pay construction workers directly to go do things, or you can pay a subcontractor. And like construction specifically is rife with all of these challenges of layers upon layers upon layers of contracting and subcontracting until you don't even like know who's paid who to show up. And we because we're using new technology on a job site because it's foreign to people, because there are a huge number of cultural considerations in mind. One of the ways that we've tackled going to market to solve this is actually just to be the contractor. So we can operate either directly as the contractor or as the subcontractor. And we're putting the onus on us to show to the market that we can provide the same or better services at the same or less expensive cost. And we can do that as a contractor by going to the homeowner. So that means we're like a licensed and insured roofing contractor registered in multiple states, whereby we can solicit homeowners to buy roofs from us and vice versa. But we can also do that as a subcontractor where a roofing contractor can come to us, or we can go to a roofing contractor and we can say, hey, we have a crew that is able to show up, tell us the time, tell us the price you'll pay, send us information about the job site and the requirements, and we'll tell you if we can show up and install that roof for you. So essentially, it just requires a lot of work, is what it does. Because before we started this business and before we got into it, I wouldn't have told you that one of the most complicated things would be convincing an insurance, not even convincing, but finding and then convincing an insurance company who wants to insure you, because roofing is a regulated industry. So, in the state of New Jersey, you have to have insurance. And in the state of Pennsylvania, you have to have insurance. And to have insurance, you need an insurance company who wants to give you an insurance. And if you go to insurance companies and you tell them, hey, we do two things, roofing and robotics, that's the Venn diagram of the highest risk things that they insure and they underwrite. So you're in a category that doesn't exist. You're in a category that's a convergence of the two worst categories in the world. And it turns out you spend a lot of time talking to underwriters about why it's worth insuring you. And it turns out there's probably only one or two underwriters in the world that are even willing to take on that risk. So it's like that's one of the like 50 things that you have to think about. And I think the reality is that at the end of the day, if you want to do the hard work of bringing this to the industry, you typically just kind of have to do it yourself, and you have to be the roofer. You have to be the one that actually installs the roof, and you have to figure out how to do it with the robot. And then the idea is that, okay, if you can do that, and if you can do that replicably, and you can show that that's scalable, then you can do one of two things. You can either convince people with big checkbooks that you're going to go and you're going to take on the entire market, and you're going to consolidate and become the biggest, most efficient roofing company in the world. Or you can go to those same people and you can say, hey, we have a replicable, scalable thing. It's this robot and way of installing roof, and give us money to build those robots and hand those robots over to people. So I think what's kind of exciting about it is that there's a lot of hard work to do, but if you can do it and you can prove it, there's actually quite a lot of flexibility when it comes to there's a big win there at the end, and there's a lot of flexibility in how you do it. And that's typically a quite exciting premise, if you can prove that it's possible, to the people that are required to make this happen, which is the big pools of capital.
But one thing that I would want to add is that, we also think as a society don't really put the proper cost on carbon, right? Like there's no, we don't actually think about cost in the long term as we should, right? For the cost of climate change for society, right? But so the actual kind of maybe benefits from Dylan's more efficient energy efficient roofs are actually not captured in the costs that he has as a contractor, because those are not costs that are relevant to a homeowner, but they're costs that are relevant to a society. And I think in a lot of times, especially in the built environment, when we talk about things like embodied carbon, right? These are upfront costs that I don't care if I live in a low embodied carbon building as a homeowner, right? But society cares, because you having a lower embodied carbon house means that, our planet has less greenhouse gases that are being emitted, right? So I think these kind of fundamental kind of long-term views are not captured in current kind of economies, right?
Really quickly, I don't want to overtake the conversation, but just to add one, maybe a way in which we're trying to creatively think about how to capture that, because I think you're absolutely right, Ramon, is that that cost is somewhere. If you follow that thread all the way back, the cost is somewhere. And if you can figure out how the system today represents that cost, you actually can have an even bigger win on the other end. And the example in roofing that we like to use is insurance. So homeowners insurance is incredibly expensive. You know, the average homeowner is paying like thousands of dollars a year to insure their home. And 50% of homeowners insurance premium payouts go to roofing companies. So people pay for homeowners insurance. They don't realize that the reason why homeowners insurance is so expensive is because of roofing, and all of that money is going back to roofers. So if you can do this, and if you can do it scalably, and if you can prove that you install better roofs, what you actually do is you don't go to the homeowner, you go to the insurance companies and you say, hey, you know, you're shelling out $40 billion a year to roofers. What if we were installing better roofs? Would you give those homeowners better better premiums for their policies? Would you cut the cost of insuring that home by 20%? But again, it's everything everywhere all at once. You have to be able to prove it, and you have to be able to convince the insurance companies and so forth. So, but yeah, I totally agree.
Yeah. Great. I think that's very, very important. That also the regulation is an impact of this, but especially the how much carbon is reduced, how much material cost is reduced through the process. And so, Stefana, I think you have a very good perspective on this, how robotics can really reduce materials, CO2 emissions, and like this be a strong case for people to adopt. I mean, is that the selling point, or is it really the human robot interface that you think is the
You kind of cut off, but I think I heard most of the question. No, I'll say it's both, and they're really connected. So in order to be able to especially work with with the available building stock, with materials that are not standardized, that are difficult to quantify as you see them without having all the information about them, I think humans are crucial. Humans are great at taking quick decisions, at understanding, you know, their environment as a whole, at reasoning. Obviously, we're really, really good. And that's exactly what allows you to work with things where you just don't know everything about them and where you need to adapt and react on the spot. So I think that the human-robot collaboration for me is crucial to be able to have these applications that honestly go beyond automating what humans have done for centuries, but towards can we make new processes that truly enable us to build differently and to say save existing structures and existing buildings. And yeah, it's a bit less for me a question of should it be automated or should it be human-robot collaboration? Yeah, I think the key is you need both, and also why would we not want to make things work for the people in the industry as well? So I might have a bit of a provocative take on the we can automate certain things. And yes, it's cheaper, but at the end of the day, and yes, I will also say in academia, yes, in the ivory tower, we can dream about many, many things. But I do think the key of the research that we do should be for the people. So can we improve working conditions? Can we make construction work actually worth it for laborers? Can we make it safer for them? Can we give them access to tools? Can we give people access to tools so they do things themselves, like so they don't need all these big companies to work there? I think all of these questions, if we can address these through automated or machines that can work with people, you can also then, address the climate questions that are behind in our existing buildings, right? Maybe you can quicker repair something, you can quicker adjust something so that you extend its life.
Okay, good. So I think we're coming to the end of the session. I would just like to get Norhan's perspective on one specific question and then ask everyone for a wrap-up comment. The wrap-up comment will be, what is your recipe of success that has brought you to where you are? You're obviously very successful being, professors, building companies, right? Leading in that field. So what was your recipe? Something that maybe others that are listening can also adopt and get inspired by. So that will be the final question. So please think of that, like a kind of half-minute answer, please, just in a nutshell, if you have some insights on that. But before that, Norhan, just briefly on the regulation, it was touched upon. So there's this ISO 55000 standard on inspection with drones and robots that are being used. Regulation is the bottleneck. Is it a bottleneck, or is the regulation there, or is the technology the bottleneck? I wonder about your perspective.
Yeah, I think this is very interesting because you can think of it from two sides. The first side is the regulations. In the context of the US, there is regulations when it comes to, I'll just speak specifically about the drones, how you can operate drones, but it's not moving fast enough. Like, for example, the guidance on how to deploy beyond visual line of sight flights, it's not fully deployed at scale yet to enable unlocking this large scale inspection. For example, when we talk about the buildings, if you want to have on every building rooftop drone unit in a box that go and inspect the building, not just for thermal imaging, but also for issues like deteriorating cladding or any kind of problems with the building surrounding, the regulations are not there yet. They're moving a little bit fast, but the market is very optimistic, especially with drones, because a lot of sectors right now are trying to adopt aerial robotics into their operations. I know, like, the Department of Transportation, for example, are using a lot of drone robotics units in their system right now. And the other side of it is also the technology. So just talking from my own experience with drones is like the battery life is one of the key challenges. There are some things that limit the duration of how the drone can fly, the area that the drone can cover in a single flight. So the technology is moving faster than regulations, but the regulations need to be applied at scale, because the US is, yes, it's going really well when it comes to the drone regulations, but there are regions where you don't have any kind of regulation. So I'm originally from Egypt, and in Egypt, we can't even fly drones, even for recreational purposes, because there is a big security concern on having drones capturing data. And there is a lot of countries in the developing world have the same challenge. So there needs to be some sort of like a model that would protect data privacy and unlock regulations in these regions, and also enable the scalability of using robotics, not just drones, similar to the BVLOS example that I mentioned.
I think that's a really common comment, that regulation is really the bottleneck here. I think another bottleneck is the success story for everyone and the recipe. We won't have time now. Unfortunately, the session is ending. So to go into that, but it's something for everyone to think about. Please also share maybe in the chat your insights on that. And it's something that we can connect to about next time. Okay, wonderful. Thank you so much, everyone, for being here. And I'm looking forward to the development of the field very much together. Have a good evening. Bye.
Thank you very much. Bye.
Thank you.